Okay, review for the test, chapter 6, 1, 2, and section 4. If you were to have this problem, what would you do? This is like the piggy bank problem. There are no powers on the outside, so you simply separate them. Numbers with numbers, letters with letters. So 4 to the negative 3 times negative 16, a to the negative 3 times a, b to the negative 6 times b to the negative 8. Correct? Then we're going to go ahead and put on our missing exponents. The 16 is missing an exponent, and the a is missing an exponent, correct? So we have 3 individual problems here. So I'm going to put this all over 1. Does the 4 stay or does the 4 go? It goes to the bottom and becomes 4 cubed. Does the negative 16 to the first power stay where it's at or go to the bottom? It stays where it's at. Then I'm going to simply do what with the exponents on my a? Which one? Do I add them or do I subtract them? They're attached by multiplication, so I add the exponents, which is exactly the same thing I'm going to do with the b's. Extend that denominator. The negative 16 stays. 4 times 4 is 16 times 4 gives me 64. Excellent job. And then this is going to be a to the negative 2, b to the negative 14. Extend the bar. Play the game again. Do I stay or do I go? Negative 16 and 64 reduce down to give you negative 1/4. Does the a to the negative 2 stay or go? Goes to the bottom and becomes a squared. Does it stay or go? The b. Goes to the bottom and becomes positive b to the 14th. Yes? Can we do it? Do we understand it? That is the first thing you need to know for the test tomorrow. We ready? Okay, next thing you need to know for the test. Okay, the first thing you should look at is inside the parentheses, you should be looking for any what? Missing exponents. Is anything missing an exponent? The 3 is missing an exponent, so you're going to put that on. Now, what do you do with the power on the outside with the power on the inside? That means you're distributing and multiplying that. So 3 to the 4th, r to the 12th, s to the negative 12. All over. The bottom, you're not going to do anything with it. Do we all understand that? Okay, so now 3 times 3 is 9. 3 times 3 is 9. So 9 times 9 gives me, and that gives you your 4 3s, right? So this gives you 81 over 9. Now what do I do with the r's? How are my r's attached? By division. So what do I do with the exponents? Subtract them. So this is r to the 12 minus negative 7. S to the negative 12 minus negative 10. And extend that fraction bar so you know where are those things at. In the numerator, right? Okay, so what is 81 divided by 9? 9 minus a negative gives you a positive. R to the 19th. S to the double negative is a positive. Negative 2. Careful of your 2's there. Your signs. Put this over 1. And the s to the second goes to the bottom. Pre-calcers in the back. You are not going to be able to take the whole period. You still got to look at your, I mean, do you want the whole period? You need to eat lunch. Okay. We all good? All right, moving right along. So what should I do with these two numerator and denominator? What should I do? Break them apart, divorce them, right? So this is the cube root of 8 over the cube root of 125, correct? One number multiplied by itself 3 times is 8. One number multiplied by itself 3 times is 125. Excellent job. My answer is 2/5. Super easy, right? Do we all understand how I'm trying to go easy, hard, back and forth? I don't want you guys to be consistently doing the same thing and then not remember how to do a harder concept. Are we writing it down? Okay, the first thing you want to do is you want to ask yourself, is 81 a perfect fourth? It is a perfect fourth. And what number multiplied by itself 4 times is 81? 3. It is 3. So we're just going to leave that on the inside there for a minute. We know it's a perfect fourth, so I leave it alone. Now, look at the variable m. Its exponent is a 15. Is my exponent, also known as the power, divisible by my root, which is 4? No, it is not. So I need to break it down into multiples of 4. 12 is the highest multiple smaller than 15 divisible by 4. And then what's left of my m's is 3 of them to create a grand total of 15, correct? Now go to the n. Is my power of 10 divisible by my root of 4? So what should that be broken down into? 8 and 2. Excellent job, guys. Okay, so now, what is the 4th root of 81? What is the 4th root of m to the 12th? M cubed. What is the 4th root of m cubed? Doesn't work, so I leave it inside. The 4th root of n to the 8th, and the 4th root of n squared. So I'm left with 3m cubed n squared times the 4th root of m cubed n squared. All right, now, if the directions were to say assume all variables are positive, I would not need to worry about absolute value bars. But since I did not indicate that the variables were positive, you have to consider absolute value bars. When are absolute value bars necessary? Even root, odd power. My root is right here, which is a 4. Is that an even root? Yes. Yes. My powers are 3 and 2. Are either one of them odd? Which ones are odd? The m is odd. So you are only going to put absolute value bars around the variable that has an odd power. Do we all understand that? You do not have to do it for the other m or n, did you say? The other m is inside the radical still, so you do not put absolute value bars around it. Okay, good question. Did you need it still? All right, next one. Everybody have a calculator with them? We all know we need one in here. Thank you, ladies. That's fine. Okay, when you approach this problem, what do you do with the numbers on the outside of the radical? So what is 2 times 7? 14. Since they have the same root, this is the root that I'm talking about, it's understood to be the same, you can multiply the junk underneath. So what is 42 times 56? 2,352 is correct. How many total x's do you have between the two of them? X squared times x to the 5th is going to be x to the 7th. How many total y's? Okay. Now, what does your number end in? A 2. So if we wanted to find the perfect square factors, we would say, okay, well, 2 squared is 4. That's super small. So what if we were to go ahead and divide it by 16? 4 squared. So is 2,352 divisible by 16? Yes, and what number is that? So 16 times 147. Since it ends in a 7, what would we likely think it is divisible by? So if it's divisible by 7, could we try 7 squared, which is 49? So what is 147 divided by 49? 3. Do we all understand that? Yes? Okay. So basically what we did is we did kind of a chart. Yes? Do we all understand that? It's a factor tree with perfect squares in it. Okay? So we're going to go ahead and make this 16 times 49 times 3. Now, is my power on my x divisible by my root? No, so what should we turn it into? X to the 6th times x is my power on my y divisible by my root of 2. Yes, it is, so I'm going to leave it alone. Everybody with me? What is the square root of 16? Square root of 49? Square root of 3? Can't do it. The square root of x to the 6th? X cubed. Square root of x? Square root of y to the 6th? Y to the what? Y cubed. Now, what do I do with all those red numbers on top of the radical symbol? Multiply them by the 14. So 14 times 4 times 7 gives you 392 x cubed y cubed times the square root of 3x. Do I need to have absolute value bars? Why? It is an even root, and I have 2 variables with odd exponents, so that must be positive, so that's why I have to have the absolute value bars. Okay, moving right along. We ready? Go. Okay. First things first. You're going to distribute, but you need to look for what? Missing powers. What is missing powers here? The 27 is missing a power, and so is the 64. How many of you would have forgotten that? You've got to tattoo it on your face, tattoo it on your hand, tattoo it in your brain. Okay, you need to get that. All right? So if we distribute that, that's 27 to the 3rd power, 6 to the x to the 2nd power, all over 64 to the 3rd, and then y to the 4/3. Okay, do we all understand that? Now, you're going to take it out of the fractional exponent concept and put it as a root. So remember, the numerator represents the power, the denominator represents the root. So this is going to be the cubed root of 27 over, or times x squared, over the cube root of 64 times the cube root of y to the 4th. Does everybody see that, yay or nay?
Yes.
My power is 1, my root is 3. My power is 1, my root is 3. My power is 4, my root is 3. Okay. You good? Yeah. Okay, what number multiplied by itself 3 times is 27? This comes out as a 3, so this is 3x squared. On the bottom, what is this going to be? 4. This comes out as a 4. And then what I want you to understand is since I'm in the denominator, I can never divide by a radical, and my power of 4 is not divisible by my root of 3. Normally, we would break it down, correct? But this is not going to help me to break it down because I'm still going to be left with a radical in the denominator. So instead of breaking it down, which direction did we go? We went up and multiplied by something that is divisible by my root. So my root is 3 and my power is 4. Give me a number bigger than 4 divisible by 3. 6 is the closest number. So I need to have 6 y's inside there. How many do I currently have? 4. How many more do I need? So I need to multiply by what I need to get 2 more y's inside there. What you do to the bottom, you must do to the top. Do we all understand that? That's what we call rationalizing. Remember this? So this is 3x squared times the cube root of 3y, the cube root of y squared. The 4 stays out there. Now, how many total y's will I have inside there? 6 of them. And what is the cube root of y to the 6th? Y squared. That is a harder problem. I really suggest you guys practice that exact problem tomorrow for the test. Okay. Let's keep on going. The square root of 0.0036. Do not use a calculator. I want work with this and show your brain. Use your brain, I should say. How did we do this? Turn it into a fraction. So this is the tenths, the hundredths, the thousands, the 10,000. So this is going to be 36 over 10,000. But I'm taking the square root of the top and the square root of the bottom. What is the square root of 36? What is the square root of 10,000? 100. And how does this reduce down to? Divide them both by 2 to give you 3 over 50. This is another rationalizing problem. There's several ways to do this problem, several. And your brain and the way you think is going to be unique, so it's really going to depend upon you how you approach this problem. I think the way I showed you guys was I went ahead and I married them back together and simplified it first. So if I marry them back together, we have this. Okay? How many x's are on top? How many x's are on the bottom? So they're going to cancel out, aren't they? The 4 x's and the 2 x's, 2 of them are going to go away from the bottom and 2 of them are going to go away from the top. And how many am I going to be left with where? 2 on the top. Very good. So your problem is going to be the square root of 5x squared over the square root of 2y cubed. because this goes away and that turns into an x squared. Do we all see that? Yes or no? Okay. So whenever we marry them, we simplify them and then we divorce them again. What is the square root of 5? Can I do it? Can I do the square root of x squared?
Yes.
And what is that? Can I take the square root of 2? No. Is my power on my y divisible by my root? No. So we're not going to mess with simplifying it. We're going to just go ahead and rationalize that. So I'm just going to recopy that. And now I want to know how many more y's do I need to run into a number divisible by my root? I only need one more because that'll give me a grand total of 4 y's in my denominator. So I need to have another y. But how many 2's do I need to have? How many more 2's do I need? I have 1 2, and how many more do I need? I need 1 more as well. So I'm going to be multiplying by 2y, the cube root of that. And that'll give me an even number. Oh, I'm sorry. I wrote the cube root there, guys, and that was so my fault. This should be the square root. I did not mean to write the cube root. That is a complete error on my part. I wrote the wrong radical. Why didn't y'all tell me I wrote the wrong radical? No, you're not crazy. I wrote the wrong radical. Okay, x times the square root of 10y divided by, how many 2's do you have in there? How many 2's do I have? 2, so that's going to cancel out to just give me 2 to the first. How many y's do I have in there? 4. So what's the square root of y to the fourth? Y squared. Yep. Okay. What I want you to do is write those as fractional exponents. So what's the saying that I always use? What is it? No. What do I always say? Power over root. So if I say power over root, that means I'm going to have y raised to 5 over 6 over y raised to the 2/3. Now, do they have the same base? Yes, y and y. So how are those two y's attached? So what am I going to do with the exponents? Subtract the exponents. So 5 over 6 minus 2/3. If you type that in the calculator, what does it give you? 1/6. Do I like that answer? Take it out of the fractional exponent and write it as a radical now. So what is the radical of this? Here's my check mark. My base is 1. My power is 1. My root is 6. Done. Can we write the 1? Y to the 1/6. Do you have? Are you asking? Do you have to write the 1 on the count? You don't have to have the 1 if you don't want to. Okay. Simplify that. And yes, that is a negative 4/3 power. Okay, what's the first thing you should do? Put on any missing exponents. What's missing an exponent? The 8. Now what do? Distribute. So this is 8 to the negative 4/3. A to the 36 over 3. Yes? Put this over 1. And what has a negative exponent? So where's that going to go? to the bottom. So this is 8 to the 4/3, and then this is going to be a to the 12. Now, take that out as a fractional exponent now, which means what are you actually doing to 8? Fourth root of, no, third root of 8. And notice how I'm going to do the power second. Because taking a power, raising something to a power makes the number larger. Taking the root makes the number smaller. So what number multiplied by itself 3 times is 8? What number is it? 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay. Simplify. So what should you do first? Yes, write it as a radical. Absolutely. So what is that going to be? However, do I want to do the root first or the square? I want to do the root first and then square it second. Because if I square 64, that's a really big number, right? What number multiplied by itself 5 times is 64? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's not going to work. 4 is too big. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, right? So this is going to be yes? So this comes out as a 2. And I have 2 times the 5th root of 2. And then you would square that. Put a 1 there. 2 squared times the 5th root of 2 squared on the inside, yes? 2 squared is 4. And this is the 5th root of 4. How do I do this problem and just write it as a base with fractional exponents? No. I get everybody with this problem every year. There are 2 separate bases inside there. The 7 is missing an exponent. It has a power of 1. The x has a power of 5. You have to treat them individually. So this is 7 to the 1/2. X to the 5 over 2. Do we all see that, yes or no? Please, 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 I promise that will be on the test tomorrow. Power over root. Yes. What about this? We did this in class in homework. So how did we go about doing this? Turn this into a fraction, right? So this is going to be x to the 1/2. X to the 3 over 2. And then this is going to be my check mark, my base of x, my power is 3, my root is 2. So it's simply the square root of x cubed. Yep. Are you talking this stuff right here? 1 and 1/2 is going to be 1 times 2, which gives you 2, and then add the numerator, which gives you 3. So it's that whole C rule that you used to do. So you multiply here and you add this. Remember that? Okay. Okay, what's 15 divided by 3? It is 5. Marry these and simplify as best you can. What is 60 divided by 12? It is 5. So now I have 5 up top. How many x's do I have in the top? 5 of them. How many do I have in the bottom? 1. So if I take 1 from the bottom and the top, what am I left with? 4 of them where? In the top. So that means this is gone, and this is gone, and this is gone. And this turns into the x to the 4th. And what you're left with is a y on the bottom, correct? Yes or no? Now, divorce them. So that's 5 times the square root of 5x to the 4th divided by the square root of y. What is the square root of 5? Can I do it? Can I do the square root of x to the 4th? Yes. And what is that? So you're going to have 5x squared times the square root of 5 all over the square root of y. Can I divide by a radical? No, and I have to have at least 2 because it's the square root to pull 1 of anything on the outside. I currently have only 1 y in the denominator. How many more y's do I need? I need another y. So what you do at the bottom, you multiply on the top as well. So this gives me 5x squared times the square root of 5y all over the square root of y squared. What happens to your power and root there? They cancel out, and you're just going to be left with 5x squared times the square root of 5y all over y. That's, again, rationalizing. We've used that term many times today. Last one, before you write it all down, simply make sure that you're looking at it. The last one turns into a 1. You don't understand that. Put on missing exponents. 5 to the negative, 3 to the negative 2 over 5 to the negative 2. X to the 12th, y to the 14th. X to the negative 15, y to the 6th. Extend that. Yes? 3 to the negative 2 is going to go where? Bottom. 5 to the negative 2 goes where? Top. Add the exponents here. Add the exponents there. And extend. What is 5 squared? 25. 3 squared is 9. X to the negative 3. Y to the 20th. Extend. What stays and what goes? 25 stays, y to the 20th stays, 9 stays, and the x cubed goes to the bottom. Listen to me. I promise you, if you study all of the problems that we did today, you will do great on the test tomorrow. If you do not study these problems, you will not do well on the test tomorrow. I have made a video right now that I will post to the internet and Edmodo. Please redo these problems tonight. I will not be here tomorrow. Am I clear? Test is tomorrow.